So here's my problem I'm starting with. I want to get us to be able to estimate area under a curve. Of course, I can get the exact area, right? Doing a definite integral, that's here. Let me do it on my calculator just to double check it, because I would like to leave. Oh, here's the drop dates again for the class. You'll see I've got 2 Monday, Wednesday, Friday drop classes, and the drop dates are the Monday the 17th. And I have 2 Tuesday, Thursday classes. Yours is a Tuesday, Thursday class. So next Tuesday is the last day you can drop. Okay? And my calculator, what a mess, huh? This desktop. You should see my actual desktop. So in my y equal, I'm putting the function. So square root of x. I want to make sure I can see my bounds in my grid. For you, it's going to be Zoom standard. So, but my calculator set at Zoom standard. So from -10 to 10, if my bounds are anywhere from -10 to 10 or interior of that, this will work. So second, calculate 7 for integral. Lower limit is 0, enter. Upper limit is 1, enter. And you see my 2/3, 0.6 repeating. Yes? So now I want to estimate using 4 rectangles. Sure. Yep. Uh-huh. Oh, I forgot not to zoom. Sorry. How fuzzy is it? That's not too bad. So I want to estimate this, right? And from 0 to 1 using 4 rectangles. So I can already visualize my delta x, right? Yes? You with me? I'm going from 0 to 1. How big is each width of the rectangle? 1/4, right? So delta x is 1 minus 0 over 4. I could use n, right? If I want to keep it really in general, I'm going to use n, and then later substitute a 4 in for n, yes? But for now, I'm going to put in the actual, I want 4 rectangles. I know I'm getting the height of the rectangles from the right corner of the rectangle. You with me? So there's the height of each rectangle. And obviously, I'm going to get something bigger than 2/3, right? Because you can see my error, right? All of this is error. What's my x sub I? Right? Well, it's 0 plus delta x over times I. So it's just I over 4. So notice when I is 1, the first place I'm getting to is 1/4. When I is 2, what am I getting to? 2/4. When I is 3, what am I getting to? 3/4. And when I is 4, I'm at 4/4 or 1 again, right? This should be really clearing up this rectangle thing for us. And then what's the height of the function is simply square root of x sub I over 4. So square root of the index over 2. Right? That's the height of the function. You with me? Now, I know I get the area is going to be approximate the sum of I equals 1 to 4 of what? Square root of I over 2 times I over 4. Oh, sorry. Yeah, 1 over 4. Delta x is 1 over 4, sorry. Right? You with me? Well, I can see that that is 1 over 8 times the sum of I equal 1 to 4 of square root of I, which is pretty simple, right? What is it? Square root of 1 plus square root of 2 plus square root of 3 plus square root of 4. Right? You with me? my delta piece I factored out, right? My delta x I kind of factored out. So what do I get here? It looks like I get 1 over 8 times, well, it's square root of 1 is 1, and square root of 4 is 2, so 3 plus rad 2 plus rad 3. And that's my estimate of my area. And then where's my calculator? Oh, I can do it on the computer here, right? 3 plus rad 2 plus rad 3 divided by 8. So 3 plus square root of 2 plus square root of 3, enter, divided by 8, 0.77. And we know the actual area was what? Up 2/3, right?
Can you go over really quickly simplifying that to a 3?
Yeah, so square root of 1 is 1, square root of 4 is 2. I added those square.
Oh my gosh, yeah.
Yeah, it's okay. It's okay. Nothing wrong. So pretty good. With only 4 rectangles, it's only off by 11 cents, right? It's not horrible. Nice. So that's definitely a possibility for your for the test or quiz in chapter 5. Estimate with a number of rectangles. Find the exact with a definite integral. And then another question would be find the exact using a Riemann sum, which was the limit, right? So let's do one like that. I tried to do one on what day is it? Tuesday? I tried to do one on Thursday. I was just going too fast. So let's do another one. So let's take a look at the integral of, let's say, from 1 to 5 of 1 minus x squared dx. The one I picked was just too complicated on last Thursday for me to go fast anyway. Now, you can do any of these you want. Just make sure you're picking polynomials up to quadratics. Even though I gave you a formula for a cubic function, I usually never go past a quadratic, okay? So any quadratic you want, and that's the function. You can double check it on your calculator. Any range you want, right? So in this particular range, right, what did I pick from 1 to 5, right? So we're talking about this area. And whenever I'm calculating the area, I'm calculating the area between the curve and the axis, x-axis. So I went from 1 to 5. So what are you noticing about this area? It's underground. So what's the sign, SIGN, going to be? Negative. So let's do the antiderivative first. Let's do the definite integral first. If I have a slope of 1, what was my original function? X, exactly. And if I have a slope of negative x squared, I'm doing the power rule here. What do I do? Add 1 to the exponent, divide by the new exponent, and then I'm going to evaluate at 5 and at 1 and subtract. So I have x minus x cubed over 3 evaluated at 5 and at 1, and then I subtract. Is everybody with me? So I have 5 minus 5 cubed over 3 minus 1 cubed over 3. So I have 15 over 3 minus 125 over 3 minus 3 over 3 plus 1 over 3. Right, I'm just distributing the negative, calculating, distributing the negative, and getting an LCD. So it looks like I have 13 over 3 minus 125 over 3. Help me. 112? Yeah, minus 112 over 3. How are we doing? We're okay? We can double check this on the calculator. Should I do that again? So you see it? Yes? In my y equal, I put in my original function, 1 minus x squared. I don't need parens around this because it just knows it as the function, or it's treating it like f of x. But then I want a graph, and I want to make sure on my grid I can see 1 to 5, right? So as long as I can see 1 to 5 on the x-axis, I'm okay. If I don't, I have to make the screen wider, right? So, but then I go to second calculate 7 for the integral, put in 1 for my lower bound and 5 for my upper bound, and there's my area. So it looks like negative 37.3 repeating. And that is negative 112 over 3. Yep. On the calculator, yeah. Yep. Oh, how did I do it? Yeah. Second, calculate. 7 for integral. Lower limit is 1. I hit 1 and enter. Upper limit is 5. I hit 5 and enter, and it gives me that area. You got it? Nice. One more time. Yep. What I want to do is just clear this out so we don't see it again. So now I've got nothing on my, if I go to my graph screen now I have nothing, right? So in y equal, I'm putting in the original function, 1 minus x squared. And then I want to make sure I look at my graph. So I just look at the graph and make sure I can see the graph with the correct range of my integral, right? Which was from 1 to 5. Domain is probably the better word there, but anyway. I go second, calculate. So there are all my options. I can find a value, I can find a 0, I can find a min, I can find a max, I can find an intersection, I can find a slope, I can find an area. So I choose 7 for the area, for the integration. And I say 1, enter, that's my lower bound. 5, enter, that's my upper bound. And it shades and gives me the area. Nice. Good. We want to find that area using an infinite number of rectangles, right? So we know that the integral from 1 to 5 of 1 minus x squared dx is the limit as n goes to infinity of the sum of I equals 1 to n. That's the first rectangle. The second, yes, question, Eduardo.
How do you know, like for the last example, you use like 4?
Yeah, so I'm gonna give you the rules of the game. Oh. Yeah, so if I say estimate using 8 rectangles, et cetera, and this one. Now, the key on the estimate one is I can't do it with these Riemann sums because I don't have a formula for square root of n or square root of an index, right? But I do have a formula for the index, right? And I'll remind you what I'm talking about in a second. And I need here what? F of x sub I times delta x. Now, I'm using right-hand rectangles only for Calc 1. For Calc 2, I use right-hand rectangles, left-hand rectangles, midpoint rectangles, trapezoids, and something called Simpson's rule, right? But I'm not going to torture all of you with this because I'm going to torture the Calc 2 students with it. Okay? Now, we have to figure out our delta x, right? That is 5 minus 1 over n, or 4 over n. And look at, if I did choose 4 again, right? How wide would each rectangle be? Right? Do you see it? How wide is each rectangle here? 1. 4 over n. So if I pick n, 4 rectangles, 4 over 4, each base is 1. Yeah. 4. X sub I is 1 plus 4 over n times the index. So I need delta x times 1, delta x times 2, delta x times 3, right? And f of x sub I is 1 minus x sub I squared. So that's 1 minus 1 plus 4i over n quantity squared, right? I'm putting in that x sub I value I found. And I want to simplify this as much as I can, so I got a FOIL. Yes, give me, so I get 16i squared over n squared. Yes, go up where?
No, right there.
Yeah. Mm-hmm. So the process is the same. Get me delta x, get me x sub I, find me f of x sub I, simplify as much as I can, and then return to my formula, right? If you need a moment, let me know, please. So I'm working on the limit as n goes to infinity of the sum of the areas of the rectangles from the first rectangle to the nth rectangle. Oh, I'm sorry, I should finish f of x sub I. Do you see that the ones cancel? So I get negative 8i over n minus 16i squared over n squared. So I'm going to put that function in, negative 8i over n minus 16i squared over n squared, times my delta x, which was 1 over 4, sorry, 1 over n, no, 4 over n, thank you. And it's easy to make a mistake. It's so complicated and so long. You just got to try and stay organized and practice. You have to practice. You don't want to do this for the first time on the test. I want to distribute there. I'm going to distribute the 4. I'm going to distribute the sum, okay? And I'm going to factor out the negative. So I've got the opposite of the limit as n goes to infinity of two sums. The sum of 32i over n squared. Do you see where that's coming from? 32i over n squared plus the sum of 64i squared over n cubed. Everybody okay here? So the negative was factored out. I know the answer is a negative. I already know the answer, right? So let me ignore the negative, I'm kind of saying. Let me just get the area as a positive number and then know I have to negate it. Now, these sums are dependent upon I. They're dependent upon the index. They're not dependent upon n. So I can pull out those pieces out of the front of each sum. So I'm getting 32 over n squared times the sum of I, because I have a formula for the sum of the indices. I have a formula for sum of I, plus 64I squared over, 64 over n cubed times the sum of I squared. And again, I have a formula for the sum of I squared, the sum of the indices squared. So not only do we do this in chapter 5 in Calc 2, in chapter 8, it turns out that we can't integrate some functions. So we learn how to rewrite them as series, and then they're easy to integrate, right? A series is easy to integrate because what is a series? Polynomial. So we learn that we can turn every single function into a polynomial. And the original function we can't integrate, but the polynomial we can. So this is chapter 8 in Calc 2. We do 5, 6, 7, 8 in Calc 2.
Why did you reorder it that way? Like, the system here, the C, or?
Yeah, exactly. Yep. So because I have this formula and I have this formula, right, on my formula sheet. So I get minus the limit as n goes to infinity of 32 over n squared times n plus 1 all over 2 plus 64 over n cubed times n plus 1 times 2n plus 1 all over 6. And again, those pieces I put in blue were on my, I learned them in pre-cal, right? I learned all that in pre-cal, but you know, you got a formula sheet. Make sure you put those all in your formula sheet. And practice, you have to practice. How are we doing? Grace, any better today? Yes? Good. I'm going a little slower. I was just trying to go too fast Thursday because I knew the quiz was long. I have quizzes to get back to you, by the way. And I'm not giving homework back again, and I don't think I'm assigning any more homework. The newest grade in Blackboard, I've dropped 6 homework grades and I've dropped 6 quizzes. Okay?
You already have, or you think?
Already did. Yes, Joanne?
If you're not signing in more homework for the rest of the semester,
You still have to do work. So the easiest thing to do is old tests. And then you certainly can look in the textbook and do problems similar to what I'm doing in the lecture.
Are you still signing every quiz Thursday though? Because I'm just worried about.
Yeah, we will have a chapter 5 quiz on Thursday of next week. And so far it's only 2. Say it again?
This is chapter 5.
Yes.
Yeah.
What I'm teaching is 5.1 to 5.4 all at the same time. So if we kind of look at it, 5.1 is the area problem. So 5.1 is figuring out area under the curve, right, using rectangles. 5.2 is the definite integral, so where I actually find the area by evaluating at the bounds and then subtracting. 5.3 is the Riemann sum, so using those rectangles and an infinite number of them. And 5.4 is the fundamental theorem of calculus, which I don't assign problems from, I just talk about, that the integral and the derivative are inverse operations, that the derivative gives me slope, and the integral gives me area, right?
You still give practice problems prepared for the tests?
Yeah, I would say everything I'm doing in the lecture is perfect.
So the quiz for this stuff is next Thursday.
Next Thursday.
Okay, so on this Thursday is like pretty much the homework for you to do.
The past Thursday, no quizzes Thursday.
Oh, no quiz.
No quizzes Thursday.
Oh, okay.
I've already got 20 some quizzes. I think 20 quizzes, and I'm dropping 6. And so Thursday I'll probably, like if I were thinking about it right now, Thursday would be this problem I'm doing only, right here, this problem. So show the left-hand side using the definite integral, show the right-hand side using the limit, check it on the calculator, right?
And then the stuff in the homework we should still expect to see again.
Say again?
The stuff in the homework we should still expect to see again.
Yeah, you're gonna see it on the second midterm.
Yeah. Okay.
Yeah, yeah. Right, I had that list.
So are you getting your quiz this Thursday or no?
This Thursday, no. I'm tired of grading, you're tired of working, right? Is that true?
But can you still give practice problems though?
Yeah, I'm saying do every one that I did in the lecture. If you want more from the book, I can do that, but
Like, can you recommend some more from the book? Just
I can. I would say probably before the book, my old tests. My old chapter 4 test, my old chapter 5 test, my old finals. You'll see it's nothing different than what I'm doing. Yeah, so this is what I'm thinking about for our midterm, these 10 problems. And I have so many integration methods. Like I said, I'm going to have probably, I think I have a list of 12 methods. And then in Calc 2, I have 12 more. And eventually all 24 fail. And then we turn things into these series, right? That's when it gets really nasty. So, I might even cut out this first one and put in another integration method, most likely. Okay? You'll be fine. You just practice. I'll update this list, right, as we get closer to the midterm. I will after I make the midterm, I'll really have a nice list for you, right? I'm not trying to do anything tricky. I'm trying to, and if you notice now, we know we're right in chapter 3. We can do the graph of the function and the graph of the derivative. We know when we're right in chapter 4, right? And so far, everything we're doing in chapter 5, you know you're right, right? Okay, back to our problem. I can simplify these pieces. Usually by this time I get bored of writing the limit as n goes to infinity, so I just start writing L. And you can already see that I got bored here too. I started writing sigma instead of the sum from I equals 1 to n, right? It's fine. It's perfectly acceptable. But I can simplify this. What do I get here? I get 16 over n times n plus 1. Is that agreeable? The 32 and the 2 canceled. The n and the n squared cancel, right? Over here, I get what? 32 over 3n squared, because the 64 and the 6 cancel, and the n and the n cubed cancel. Everybody with me? I'm doing my algebra now as I choose to. You do your algebra as you choose to, right? Typically, we do things the way our teachers taught us, or we come up with our own method because we hated what our teachers taught us, right? So, but either way, do what you know, any way you want. I'm going to distribute here. So I get a 16 n over n times n plus a 16 over n times 1. And then here I've got my 32 over 3n squared, and I get 2n squared plus 3n plus 1. Make sure you're with me. Oh, do I have your quizzes here? No, I don't. I'm sure it's like 24 or something like that, both quizzes and homework. Okay, I'm going to distribute the 32 over 3n squared, and I'm going to simplify things if I can. So I've got a 16 here. I've got a 16 over n here. I've got a 32 over 3n squared times a 2n squared, plus a 32 over 3n squared times a 3n, plus a 32 over 3n squared times 1. I want to simplify, but don't let me go too fast. Everybody with me? Anybody need a moment? So I've got the opposite of the limit of 16 plus 16 over n plus 64 over 3 plus 32 over n plus 32 over n squared. I'm just simplifying things, right? Is that good enough? The n squareds cancel here, the 3's cancel here, the n's cancel, nothing cancels. Where did I forget a 3? Oh, yes, thank you. And why did I make that mistake? I know it's going away anyway, so I get lazy. I stop thinking about what I'm doing and start thinking about what's going to happen, and that's when I make a mistake. Same thing that happens when you're driving. When most accidents happen close to home, you're coming around the 2 more turns, you're home, and you're thinking, what am I going to make for dinner? And you run over some kid. Stay focused on what you're doing, right? What happens to all of my limits when I'm dividing a constant by n, or n squared, or n cubed? What happens to all of them? They all go to 0. So I've got the opposite of 16 plus 0 plus 64 over 3 plus 0 plus 0, right? Notice my limit's gone. I let n go to infinity, and all of those pieces where the denominator is dominating goes to 0. So it looks like I have a final answer of minus 16 over plus 64 over 3. I'm going to multiply the 16 by 3, right? What is that? 48 plus 64 over 3. It looks like I got it, negative 112 over 3. Oh, that's awesome. Now, here's what's going to happen on your test. You're going to get the integral right using the calculator. You're going to get the integral right using the integration, right? Definite integral, where I plug in the numbers at the end. And you're going to get this part wrong, and you're going to freak, right? So what you're going to do on the quiz and on the midterm and on the final is you're going to say, all right, let me make sure I do everything else, right? Or let me look at my work and see if I see an obvious mistake. Let me make sure I get the rest of the quiz done, and then brand new piece of paper, do that part of the problem over. You will be writing like a mad person. Someone will come by the room and we'll see everybody writing and shards of pencil and paper going up in the air, right? But that's how you have to work. You have to be constantly writing. To do that, you must practice. If you don't know what to do, you can't constantly be writing, and you will never get it done. It's a lot of work. You have to go as fast as you can, staying focused on what you're doing at the time, not future, right? Not looking at the future, trying to make sure you're not making mistakes, right? And if you do make a mistake, you don't panic. Remember in high school, we didn't have to do shit? You didn't have to do anything. Did anybody else have that experience? In high school, we did nothing and we passed? Did you, only 2, 3 of you were like that? It's not the case anymore. You have to learn how to be a student. It's around Calc 2 when I finally learned how to be an excellent student. Still got a couple of B's and two C's. One at the senior year, one at sophomore year, right before I graduated from my community college, and one as a senior at the university.
Is there a reason you waited until the third to the last line to make n zero?
Yeah, no, n infinity, right? I let the number of rectangles go to an infinite number of rectangles. Yeah, I wanted to get everything to the point where I could see clearly what would stick around and what would go to zero. And I'm trying to communicate that to you. I already know that I'm only going to get the leading piece of this one and the leading piece of this one, right? I already know that, but I'm trying to communicate to whoever's reading it. Yes? Claire?
Okay, wait, actually, I think I'm good. I don't
Okay.
have a question.
Okay. Nice. Let's take a break and we'll start doing some integration methods. So let's see, it's 9:57. Let's come back at 10:05.